Hello friends, this is second problem on a cable which we are going to solve by Lem's theorem. Let me read the statement given first. The problem goes like this: the system of connected flexible cable shown in figure is supporting two loads of 400 Newton and 500 Newton at points B and D respectively. Determine the tensions in the various segments of the cable. This problem is slightly different from the problem which was solved earlier. In the previous problem, there was only one joint, and the question asked is to calculate the tension in B and VC. So here we have two more joints, so that we need to apply the Lami's theorem at B as well as at D. Now here let us try to understand what is joint. If more than two number of members come in contact from a single point, that we can consider as a joint. Now, so as I told, A is not a joint, whereas C is not a joint, whereas E is not a joint. But B and D are a joint because more than two members are meeting at this point. So this can be considered as a joint. So now let us try to draw the free body diagram first. Free body diagram we need to draw separately at B and D separately. So free body diagram at B. So I will repeat the procedure. First we need to draw the plus mark. Then a vertical force of 400 Newton is acting vertically down. In this portion is inclined. I will draw here, and the force in this member we don't know. Again here we have one more member, and the force member, this is also not known, but this angle is given as 30, whereas this angle with respect to vertical it is given as 60. So here we have one more portion, and what I did is I have removed this fixed support, and a portion BD. So as we know that these are the cables, so in all the members, when I consider joint B, this become TBC, tension in portion BC, this become tension in portion BD, and this become tension in portion BA, right? So now look at here, the difficulty arises here is, as we have a limitation there, so we can only solve a problem, or we can say Lami's theorem can be applied only when there are two number of unknowns and one is known. In this case we have three number of unknowns along with the known force, only four forces we have, so we cannot apply directly the Lami's theorem here. So it's very difficult. As I told you in the beginning of the Lami's theorem class, we have a limitation that Lami's theorem can be applied only when we have three forces in which one is known and two are unknown. Okay, so here we can apply directly. So what we do, I will make your second next joint. So I will draw the free body diagram of a particular joint, that is D. Let me draw the plus mark and show the unknown forces. Now here we have one segment, that is DE. So I will write tension in DE. Always we need to consider the direction of tensile force should be moving away from the joint considered. Okay, now in this portion we have BD. So look at here, try to understand. When I consider joint B, the force in portion BD I have taken from B, the direction away from the joint. When I consider joint D, again the direction of the force BD should be away from the joint, because tensile always act away from the joint considered. Okay, now next we have a force which is of 500 Newton acting vertically down. This angle is given, look at here, I will draw here the portion DE, something like this. So this angle is given as 45. At E it is, when I consider at B, D, this angle will be 45. Similarly, for this portion, this angle is 60. It means at D, this angle will be 60 with respect to y. So same thing I will take here with respect to y. This is 45 degree. At a d, this angle will be 60. Okay. In this free body diagram, one force is known, 500 is known, whereas two other are known. So totally we have three forces in which one is known and two are unknown. Here I can easily apply the Lem's theorem. So we need the other angles to apply the Lem's theorem. So in the first quadrant, if this angle is 45, remaining angle is 45. Similarly, in second quadrant, if this angle is 60, remaining angle is 30. Third quadrant, there is no force, so it is full 90, and this is 90. Now first apply Lem's equation at D, joint D. First write known force, which is 500 divided by sine of. Now look at here, I have considered known force is 500 and the opposite two forces BD and DE. Opposite two, so the angle between these two is 60 plus 45. So we'll take here 60 plus 45 is equal to, I will first consider TBD divided by sine of. When I consider TBD, the opposite two forces become DE and 500. The angle between these two is 90 plus 45, which is equal to TDE divided by sine of angle between opposite two forces. When I consider TDE, the opposite two forces becomes 500 and TBD. The angle between these two is 90 plus 30. Now 500 divided by sine of 60 plus 45 is 105 is equal to TBD sine of 135 is equal to TDE divided by sine of 120. Consider first two, we will get TBD. I will write directly 500 into, just cross multiply, sine 135 divided by sine 105, and TDE is equal to 500 sine 120 divided by sine 105. This I will make use of a calculator. Now 500 into sine 135 divided by sine 105 into 366.025, and as the load is going in Newton, so answer will be in Newton. Again 500 into sine 120 divided by sine of 105. This is the answer. Okay, I have taken the free body diagram of joint B. It is a free body diagram of joint B. In this case, we have totally 4 number of forces, but in a previous case, we have calculated TBD, because TBD will be equal to TDB. We got an answer of TBD as 366.025. Okay, and look at here. Here we have 4 number of forces. So remaining angle there is no need to calculate, because we are not going to apply the Lem's theorem, as we have limitations that we can only apply Lem's theorem when we have only 3 number of forces. In this case we have 4 number of forces, so here we cannot apply Lem's theorem. So what we need to do is again draw a plus. Okay, we need to resolve the forces which are inclined here. TBA 400 show as it is, because these are acting on x and y. I have shown as it is. Whereas TBC, the angle for TBC is given with respect to y, so y component is TBC cos 30, and along x it is TBC sin 30. Similarly, when I resolve this TBD, because angle made by TBC BD is again with respect to y it is 60, so y component, when I bring this force along y, it is acting downward, so it is TBD cos 60 and x component will be TBD sin 60. Now we'll apply the equilibrium condition. Summation of h is equal to 0 and summation of v is equal to 0. We'll add the forces acting on x direction and equal to 0, and we add the forces acting on y direction and equal to 0. So first we'll apply this summation of h is equal to 0. It means that we need to apply this summation of h is equal to 0. It means we need to add the forces acting on all the forces acting on x and equal to 0. So we'll start with the positive right side acting forces. Our sign convention is right side acting force are positive, left side acting force are negative. So TBC sin 30 is acting towards the right, so plus TBD sin 60 minus TBA is equal to 0. So in this too we know the value of TBD. So substitute here TBC sin 30 plus TBD, where TBD is 366.025 sin 60 minus TBA is equal to 0. So here we know TBC sin 30 minus TBA, take this into RHS, become minus 366.025 into sin 60. So we get minus 316.986. Call this as equation number 1. Now we'll add the forces acting along y direction. Here the sign upward acting force are positive, downward acting force are negative. This is a sign convention. So here TBC cos 30, this force which is acting upward, plus minus TBD cos 60 minus 400 is equal to 0. Here we know the value of TBD again. So TBC cos 30 366.025 cos 60 minus 400 is equal to 0. So add this two and take to RHS. So here we get TBC cos 30 is equal to, when this 2 goes to RHS, become plus. So I will make use of calculation now here. 366.025 cos 60 both become plus, so 400. $583.012. Now we want TBC. TBC is equal to 583.0125 divided by cos 30. 583.02 divided by cos 30 gives you TBC 673.20 TBC it is. If you want TBA, substitute the value of TBC in equation 1. TBC, we want TBA, so I will read from equation 1. We want TBA, so I will rearrange the equation 1. So TBA will be given as TBC 673.20 sin 30. Then this minus comes to left hand side, become plus 316.9806 into sin 30 plus 316.986. This is the answer.